This is the next video in the chapter on stoichiometry of chemical reactions. We are finally going to talk about stoichiometry, as well as how to determine the limiting reagent and how to calculate the percent yield of a reaction. So let's look at where we have been so far. We just finished a long discussion of the three major types of reactions: precipitation, acid-base, and redox. And we learned to predict the products for each. So we have learned to predict the products of three different reaction types. And that's good. That's a very valuable skill to be able to predict what the products are. And now we're going to take it a step further, and we are going to predict how much of each product we could possibly make from the amount of reactants that is given. So now we can include more detail in our prediction. We can predict how much of each product is produced. So how much is going to be our new focus? So we'll start by talking about stoichiometry, which will directly lead us to the answer to that question. So this is kind of a scary, difficult to spell word because it comes from two Greek words. It comes from the word stoichion, which means element, and the word metron, which means to measure. So stoichiometry is about measuring how much of each piece in a reaction we have related to each other. Stoichiometry is about relating the amount of different reactants and products to each other. And you may not know it, but you have been using stoichiometry for your whole life. You probably just didn't realize you were using it because you didn't use this weird fancy word and you weren't taking a chemistry class. So nobody told you about the awesome life skills that you already have. Most likely, one of the times you used it was the last time you made pancakes from a box mix that you got from the store, or brownies, if that's your deal. So here's a typical reaction that would be written in the form of words on the pancake mix box. It would probably say something like, if you take 1 cup of this pancake mix that has all the other pieces mixed together already, you add in 3/4 cup of milk and 1 egg, that'll make 8 pancakes for you to love and enjoy. And so what we can do with stoichiometry is we can start to change some of these amounts and look at how it will affect the amount of the other pieces that we will need or produce. So for example, if I wanted to know how many eggs I needed to make 24 pancakes, because I just love pancakes so much that I want to meet them for every meal of the day, 3 meals, 8 pancakes each, 24. You can probably do this in your head. You can probably say to me, oh, Rachel, 24 pancakes, 3 eggs are required. But this is chemistry, and in chemistry, we solve math problems with dimensional analysis. And eventually the problems will get complicated enough that you can't do it in your head. So let's talk process. So if I want to make 24 pancakes, I need to use a ratio that comes from the stoichiometric coefficients in front of these different amounts to relate the number of pancakes to the number of eggs. And it's the same as doing a conversion factor to convert from grams to milligrams or something else you're more familiar with. We put pancakes on the bottom so it cancels. We put eggs on the top so we end up with that. Then we take the conversion numbers from the balanced equation. So we've got 8 pancakes for every 1 egg. And so pancakes and pancakes will cancel. 24 times 1/8 is 3 eggs. So you were secretly doing chemistry all along every time you doubled a mix. So this thing here, we called this a conversion factor when we first learned dimensional analysis. This particular type of conversion factor, I'm going to call a stoichiometric ratio. And that just means it's a conversion factor where the numbers I'm using to convert come from a balanced chemical reaction. Let's try another one. Let's say I wanted to have pancakes 3 meals a day. So I wanted to make 24 pancakes. How many cups of milk? Again, we can use a similar process. We know we want to make 24 pancakes. I want to make a ratio out of pancakes and milk from this equation. So I'm going to put 8 pancakes on the bottom. And I'm going to put 3/4 cup milk on the top. Usually in chemical reactions, we prefer to have integers, but we'll just go with it because cooking and chemistry are related but not the same. The pancakes and pancakes cancel, multiply through, and we get 2¼ cups of milk, or 9/4. Now we solved this in the same way that we solved the last one. We had a reactant here on the top, and we had a product here on the bottom. But stoichiometric ratios don't have to be between one reactant and one product. They can be between 2 reactants. They can be between 2 products if you happen to have more than one, or they can be between any reactant and any product. So we can solve this problem a different way if we know how much of one of the other reactants we happen to have. And it just so happens we know we need 3 eggs to make 24 pancakes because we did that in the last problem. So another way you could solve the problem if you had more information was to start with the number of eggs and take the ratio of milk to eggs instead of milk to pancakes. So we can do 3/4 cup milk on the top over 1 egg, with egg canceling, giving us the same answer, 2¼ cups of milk needed to make 24 pancakes. So you can see in this second ratio, and the second time we did it, we have a ratio of 1 reactant to another reactant. So I am obviously not suggesting that you solve every problem twice in every possible way. I am indicating that these stoichiometric ratios can be a reactant to a reactant, a product to a product, or a reactant to a product. In the next video, we will use an actual chemical equation that does not involve pancakes, and we will learn more about stoichiometric ratios.